Most people spend around $48,000 on a new vehicle, or $28,000 on a used one, and then they try to save a few dollars on the singular component that actually fires the whole machine to life. That specific choice quietly cracks pistons, damages fuel economy, and sends drivers crawling to repair shops with invoices they never saw coming. Right now, incorrect specifications and counterfeit spark plugs sit on shelves and online listings that will genuinely damage your daily driver, and buyers purchase them constantly. On the other side of the aisle, you have numerous options forged from materials tough enough to outlast your loan payments, with some pushing past 100,000 miles without flinching. Before your next tune-up, reviewing these differences remains essential. A spark plug sits at the very top of each cylinder chamber. When the motor runs, that space compresses a tightly controlled mixture of air and gasoline. A concentrated bolt of electricity up to 60,000 volts ignites that fuel instantly, driving a steel piston downward to push your car forward. This process repeats thousands of times per minute while you drive, meaning a component firing even a fraction of a millisecond late utterly destroys the timing. Your car shakes violently, fuel efficiency drops overnight, and the control system starts throwing error codes across the dashboard. The check engine light just sits there glowing orange while you keep driving and hoping the problem resolves itself, though it rarely does. Counterfeits top the danger list, as fake NGK and Denso hardware flood online marketplaces continuously. Identical boxes and logos arrive wrapped in perfect packaging, but the core inside consists of a cheap alloy utterly incapable of surviving actual operating heat. One mechanic published clear documentation of a single counterfeit piece causing over $3,000 in internal damage after melted debris fell straight into the cylinder. This destruction happened all for a part that sold for $6. These fakes look flawless right up until the exact second they disintegrate, making them extremely risky. Buying from a physical parts store, walking in, handing over the part number, and purchasing off the shelf heavily reduces your risk, though you should still inspect the hardware closely. Generic unbranded parts carry a similar catastrophic risk dressed in different clothes. They offer zero branding and zero engineering data, providing just a stark white box, an aggressive price tag, and a material composition nobody bothered testing under real-world pressure. Weak materials mean dangerously low heat tolerance, causing the central electrode tip to rapidly burn away within 10,000 miles, or sometimes sooner. Replacing them every few months over a decade of use means you suddenly spent triple what genuine iridium costs. Cheap alternatives end up being far more expensive in the long run every single time. Standard copper sits in the third spot on the avoid list, but it requires an important asterisk. Copper itself functions beautifully for carbureted classics built before 1990 and vintage muscle cars. The disaster starts when someone forces copper into a modern power plant built in 2005 or newer. Contemporary motors run hotter, tighter, and at vastly higher compression ratios than anything rolling out of the 1970s, and copper survives roughly 20,000 miles under those brutal conditions. Manufacturers built modern vehicles to run six figures on the odometer between tune-ups. Choosing the wrong application means you end up climbing under that hood 5 separate times, while a neighbor with the correct hardware touches theirs exactly once. Multi-ground designs come next, and this particular design choice deserves real frustration. 2, 3, or sometimes 4 ground straps sit wrapped tightly around the firing tip. Marketing departments call it advanced ignition technology, while physics calls it crowding. Electricity takes the path of least resistance, rather than magically splitting across 4 separate electrodes simultaneously. Those extra structural arms block critical open space right around the ignition zone, meaning the vital air-fuel mixture burns less cleanly than it should. Independent engineers testing these designs in controlled environments documented reduced firing performance compared to a standard single-ground piece. They are often marketed as an upgrade, but were actually designed as a cheaper alternative to precious metals, leaving your car performing measurably worse. The fifth item to avoid involves selecting the wrong heat ranges. Each unit carries a specific rating describing precisely how fast the tip transfers heat away from itself between power cycles. Buying an option running too hot for your specific application causes that firing tip to stay glowing bright red between sparks. That lingering glow ignites the air-fuel mixture before the computer actually calls for ignition, creating violent and uncontrolled explosions slamming inside the chamber. Those explosions burn holes straight through solid aluminum pistons, creating severe structural failure rather than just surface damage. Piston replacement on a basic four-cylinder starts around $900, and on a V8 truck, you should budget $3,000 minimum. Taking 5 minutes to check the owner's manual for the exact specification prevents that entire financial nightmare. So always match the exact number and never guess. Several options successfully earn your money back through pure longevity, fuel efficiency, and uncompromised system health. NGK Laser Iridium leads the charge, as Honda and Toyota both selected this specific model at the factory assembly level. Their engineering teams evaluated every available ignition component and landed right here. Real-world drivers consistently report hitting high mileage marks with smooth idle performance virtually unchanged from day one. NGK uses precise laser welding to bond the exotic element tip straight to the electrode, preventing it from snapping off, while the iridium itself prevents cracking under severe thermal stress. If you drive a Civic, Accord, Camry, or Corolla, this provides the definitive answer. Denso Iridium TT takes the second spot, featuring a center electrode made of this ultra-hard material, while the ground electrode utilizes a durable platinum alloy. The center tip measures a minuscule 0.4 millimeters, and the ground measures 0.7 millimeters. That intensely concentrated spark point improves burn efficiency enough that real drivers document gaining 1 to 2 miles per gallon immediately after ditching worn-out copper. Denso originally engineered this architecture as original equipment for luxury and performance street cars before finally adapting it for the broader aftermarket. Your daily commuter gets race-developed ignition technology for around $12 each. Bosch Double Iridium answers a very specific need for European auto owners. VW, BMW, Audi, and Mercedes motors run significantly higher compression than most American designs, wearing standard parts down quickly. Bosch applies precious iridium to both electrode surfaces, utilizing laser fusion welding, officially rating them for years of driving across most European applications. If your import currently suffers from worn components, the cold start improvement after installing these is something you feel the very next morning. NGK Ruthenium HX represents the forefront of material science, as ruthenium stubbornly holds its shape under extreme heat that causes lesser alloys to gradually soften. For turbocharged setups, that distinction matters enormously. Turbos generate exponentially more heat at the cylinder head than naturally aspirated counterparts, and hardware unable to bridge that thermal gap breaks down prematurely. Vehicles leaving the factory equipped with a turbocharger benefit greatly from the Ruthenium HX, making it worth the extra investment. 3 distinct options built specifically for the big 3 American families deserve mention together. AC Delco Professional Iridium heavily dominates the General Motors lineup, covering the Silverado, Sierra, Tahoe, and Suburban. Every single GM truck benefits from a design engineered specifically to match their demanding engine architectures. 80,000 miles of standard driving on these is just normal use, though regular heavy towing requires earlier inspections. In the Ford camp, Motorcraft Iridium takes the primary position. Ford's engineering team worked directly alongside Motorcraft to calibrate these perfectly for complex EcoBoost and V8 firing characteristics. Drivers swapping to Motorcraft after suffering through mismatched parts watch rough idles vanish at stoplights almost instantly. Champion Iridium covers the Chrysler, Dodge, and Jeep family without making flashy claims or relying on fake extra ground straps. These units just work reliably through tens of thousands of grueling miles, which explains why Chrysler dealerships have stocked them for decades. Autolite Iridium XP earns its spot by being honest about what it delivers, offering genuine precious element construction priced right around $8 to $12 at most stores. For drivers carefully watching their budget who still demand real longevity from an ignition system, this option delivers over 70,000 miles of reliable service without demanding premium prices. Spending $20 each on a 12-year-old vehicle pushing high mileage serves no practical purpose, and Autolite XP provides the undeniably smart answer for those older applications. NGK Iridium IN carries a specific value for owners of older platforms. If your ride originally ran basic copper from the factory and you desperately want better cold weather starts, this upgrade delivers. It stops needing replacement every year or two and closes the technology gap at a reasonable price point. Aging motor designs see notable improvement from the ultra-fine center electrode that modern technology allows. That weathered 2003 pickup will feel noticeably transformed after installing a fresh set. Closing out the heavy hitters is Denso Long Life, where extreme longevity and durability serve as the absolute central design goal. For drivers battling northern winters, where road salt mercilessly attacks every exposed component from October through April, an option actively resisting rust and chemical degradation extends service life dramatically. Denso rates these for an extended long-term lifespan under standard conditions, creating a part you never need to think about again after tightening it down. Changing these yourself takes roughly 1 hour on most vehicles. The process requires a dedicated socket, a socket extension, a spark plug gap tool, a standard ratchet, a torque wrench, and the owner's manual flipped open to the specification page. Paying a mechanic $300 for a task this remarkably simple remains unnecessary. You can execute this swap on a quiet Saturday morning and put that hard-earned cash toward gas, groceries, or anything else you actually need. Your car already gives clear signals when the ignition system fails, producing hard starts on freezing mornings when the starter cranks twice as long before catching. You might experience a violently rough, shaking idle at red lights that feels like the entire chassis is hiccuping under the hood, alongside fuel economy quietly dropping 2 or 3 miles per gallon with zero obvious explanation. These undeniable signs indicate a failing system, and in almost every single case, a fresh set of quality hardware from this list permanently fixes all 3 of those maddening problems in a single afternoon. Avoid the shameless counterfeits from unverified online sellers and walk right past the generic white box traps. Only use standard copper if your specific motor calls for it, or if you are running a modified high-performance setup. Leave the multi-ground designs gathering dust on the shelf where they belong, and never install anything without rigorously confirming the heat range matches your specific application. Executing those 5 steps and selecting the correct option from this list ensures your vehicle will run cleaner, start faster, and burn vastly less fuel for the next decade of use. The system executes hundreds of millions of ignitions over its lifetime, requiring parts that can actually survive the intense operating conditions.